Hi, today we will learn about linear regression. This is one of the model in machine learning algorithms. We will learn this by solving one example. Consider one example, that is years of experience and package. Suppose for 2 years the package is 3 LPA, for 4 the package is 5 LPA, for 5 years it is 6. For 9 years what will be his package? This is a question. So we will solve this and we will find the for 9 years what will be his package by using linear regression. Okay, we can solve linear regression by using two approaches, that is OLS, ordinary least squares, and another one is gradient descent. By using these two approaches we can solve the linear regression problem. In this video we will talk about ordinary least squares. Okay, before that we'll plot one graph between years of experience and package. 2 4 6 8 10. Okay, first for 2 years it will be 3 LPA, for 4 years it will be like 5 LPA, for 5 it is like 6 LPA. So here our aim is to, we need to find one line. That line should pass through all the data points, all these data points. Otherwise we can say that line should pass through the minimum distance from the all the data points. For example, if our data points is like this, then our line should pass through minimum distance from the all the data points. Consider this line. Okay, if we find this line, then we can say simply for 9 years it will be around 10 lakhs, or we can say 10 lakhs. So in this way we can find the solution for our problem. So how to find the best fit line? Our objective is to finding best fit line. So how we can find? In mathematics, line means we can represent as mx plus c. M means slope, c means intercept. So we need to find m and c in such a way that it should fit in all the data points or the minimum distance from data points. So the error should be minimum. Error means what? Suppose this is our prediction, this is the data points. Consider this as y1, y2. Since it is a predicted, we call it as y1 cap. This is the actual, this is a predicted. So the error will be, this is the actual, this is the predicted. Here we can't simply just add it, because suppose consider here the error will be 2, here the error will be minus 2. If we add 2 minus 2, then error will be 0. So what we will do is we will square the error, then it will not equal to 0. Similarly for y2 also, actual minus predicted, and so on till n. What is this? Sum of squares. This is the first approach, ordinary least square. So what is our aim? We need to find the least of the squares. Means we need to find the least of this error. we call it as as, and all this we can written as summation I equal to 1 to n ya minus ya cap whole square. We can call it as like this. So we need to find this sum of squares should be a minimum. Okay, this line means our prediction y cap mx plus c. We can write m as beta 1 and c as beta naught. Beta 1 means slope and beta naught means intercept. Intercept means at which point our line cutting the y-axis. This is the intercept. So we can substitute this y cap in S equation. Then it will become summation I equal to 1 to n. We simply can written as summation yi minus beta 1 xi minus beta naught whole square. Okay, so here our aim is to we need to find the minimum of this s. In mathematics, if you want to find minimum of any function, then you need to derive that function with respect to the unknowns, and you need to equate that to 0. For example, if you want to find the minimum of s, then you need to derive that s with respect to unknowns. Here unknowns will be b1 beta 1 and beta naught. 0 similarly equal to 0. So if you find beta 1 value and beta naught value in such a way that by using these equations, then this function will be minimum error possible. Before that, we need to understand some of the basics of derivatives. That is, derivative of x square will be 2x, and according to chain rule we need to derive this x again. Derivative of this x will be 1. In total it will be 2x. And also if we derive anything constant 1 or 2 which not includes this function is, then it will be 0. These two basics we need to understand. Okay, here we need to derive this function. It is in the form of x square, so derivative of x square will become 2x. So we can written it as 2x. And again we need to derive this is x function because according to chain rule. So since we are derivating with respect to beta 1, if any term not containing beta 1 will be taken as constant as this, then it will be simply 0. In yi term we don't have beta 1 value, so it will be 0 minus it contains beta 1 values, so it will be xi minus beta naught 0. Since we get to 0 equal to 0, we will take minus 2 into front. By dividing minus 2 on both sides we will get, and by multiplying xi with all the remaining terms. Okay, by expanding these terms we will get so consider this as equation 1. Similarly, we need to derive this is function with respect to beta naught this time. Since it is a x square, derivation of this term will become 2x and again according to chain rule we need to derive this again. Since we are deriving with respect to beta naught, this term not contain beta naught, so it will become 0. This term also become 0. This term contains beta naught, so it will become minus 1 equal to 0. Take minus 2 out. Dividing minus 2 on both sides, we will get here summation of beta naught we can simply written as beta naught, n into beta naught. Okay, rearranging these terms. Consider this as equation 2. Now we will substitute this equation 2 into equation 1, that is beta naught value. So we have substituted this beta naught value here. Now we will expand this term. Summation xi into summation yi into summation xi minus beta 1 into summation xi into summation xi whole square divided by n. Okay, multiplying n on both sides, it will become okay. By rearranging we will get okay, here minus into minus will be plus. By rearranging so this will be our beta 1 value. Coming to beta naught, we can write simply we can write by n as y mean and x mean. Beta naught value will be, so we found the beta 1 value and beta naught value. In next video we will substitute our years of experience and package values in beta naught and beta 1 value, and we will find the beta 1 and beta naught value. Then we will substitute in our y cap. Then we will find the what will be the package for 9 years of experience. In next video we will do that. Thank you.